Hey Bernhard.
Hi, Carsten. So in this video, we talked in the previous ones about the routing, right? Now
Yeah.
it's switching time. So let me do a recap of one node, right? So that's the picture we developed, right? So we talked about the individual node, the networks, from the physical port to the virtual adapters that we have created. But as you see, there are a lot of physical ports below, all right? And these ones need to be connected because we have a lot of servers. So let's switch over to the switches.
Yeah, this is one of my artwork, I would say. So I do this slide. So you spoke about the physical NICs that are the PNICs, and
Mhm,
as we saw in our cluster, we have all these VNICs, these virtual NICs. But the PNICs have to be connected to physical switches,
mhm,
and this is now we do some connections. So please press click the first time. This is the BMC adapter, the BMC
mhm.
adapter of the host. We use the BMC for the installing
Yep.
to connect to the bare metal controller where we have different possibilities, also a remote console.
Mhm,
This is
okay.
obviously connected to our 1 gigabit switches because it's a 1 gigabit AG45 port. But
Mhm,
this is not important for our cluster. It's just that we can connect to the nodes. So then we have to connect our management switch. And because we want it redundant, we
mhm,
connect the left port to the left gigabit switch and
mhm,
the right port through the right to the right gigabit switch. And bear with me, when you follow the line, it's going behind the node so that
mm.
don't have so many crosses over the picture, right? So now we have everything for our 1 gigabit
Mhm,
connections. And now we have some fun with our high performance NICs. We have two 25 gigabit NICs that are used for the VM switch. The right one we connect to the right 100 gigabit switch.
mhm,
And you could say you have 100 gigabit ports in the switches, but it's only a 25 gigabit NIC. That's not the same. One is SFP28 and the other is QSFP28. So there are cables available where you on one side have a 100 gig port and on the other side you have four 25 gigabit ports. And I use those cables here.
mhm,
So then we connect the other port to the left switch. Same. And now we connect our 100 gigabit ports from our storage switch. The right one again to the right switch and the left one again to the left switch.
mhm.
So this is the cabling, and it's a bit confused because I go behind the switch with the cable to the first port. Okay.
Okay. But
Yes.
okay, good.
Otherwise, otherwise we don't have enough space.
We
So
are
now
not the
let's
drawing
look at
experts, but yeah.
yeah. So now let's look at four nodes.
Yeah, but first of all, it's maybe worth mentioning to do some adapter teaming, or that's what we did, right, in our
Yeah.
setup. So just to
Yeah.
make sure that the virtual adapters, right, which you have on top there are sort of pinned to the physical NIC
Yeah.
port.
So
Um,
all the one adapters, so class one, REPL one, SMB one, are bound to the left 100 gig port.
mhm,
We talked about that in the videos before, and we also did
right.
the team adapter mapping. Yeah, but it's
Mhm, yeah.
important that we we uh, we that our traffic, our high performance traffic, stays in the switch. So
Yep.
every node on in the site is connected to that switch, and it doesn't go over to the other switch. Yeah.
Mhm,
Okay.
yeah.
So
Okay.
let's now go to a bit more complex
Yeah. And the next
picture,
slide.
right?
Okay.
Yes, the next one. So now we look at the same switches and we have four nodes. And
Mhm,
to be honest here, this is not our preferred network setup. We will go to that in the next slide, but I only have those switches.
mhm,
I don't have four Mellanox switches and four Ubiquiti switches for this setup. But in a real stretch scenario, we will put multiple switches in one side. Unfortunately, my CFO doesn't give me enough money to buy 4 Mellanox switches to do this video. So we have to do it with the switches we have. And I have seen these scenarios also out at customers, but I would not. I don't
Okay,
prefer this scenario.
before you talk about why not, maybe you should
Yeah.
explain first what we have, right? Because
Okay.
okay,
What do we
I
have?
think the message is clear. We have budget constraints, right?
Yes,
And
exactly.
that's why we did it this way, right? Okay. So okay, let me
Do you
animate.
want to draw some lines here, because this picture doesn't have too much lines? Some are here. So our Ubiquiti network is connected to a firewall, and over
Yeah.
that firewall we can reach Azure, because
Hmm.
we have an Azure Stack HCI cluster. It has to occasionally it has to communicate with Azure. So
Hmm.
our Ubiquiti switches, of course, are connected. Yeah.
Hmm.
So
And they are.
yeah,
Mhm.
cross connected. Then
Okay.
our
And
Mellanox switches are also cross connected. Yeah.
mhm.
And because our VM adapters, where our virtual machines are connecting over, these VM adapters are connected to the
Mhm.
Mellanox switches, and we want the possibility that our VMs can communicate to our
Okay.
clients. That clients are usually connected to the 1 gigabit network in this example,
Okay.
and maybe want to go to the internet. So we have also to connect our Mellanox switches to the Ubiquiti switches.
Okay,
Yeah.
so let me just put that. So that means a virtual machine on node number one should be able to talk to a virtual machine that is sitting on node number four. And therefore we need the
Yeah, this
reddish
is
interconnect,
possible with the
right?
interconnect, right, Bernhard?
Right.
But if they
Yeah.
want to communicate, if you want to communicate from your notebook with this
Hmm.
virtual machine, you can't do
Hmm.
that, because you are coming over the internet, maybe.
Yeah.
In our AVD series, we did that. You
Hmm.
connected to a virtual desktop on my hosts here, and for that we need these
Hmm.
blue lines, right? So
Yeah.
our Mellanox switches
Correct.
have to be connected to the Ubiquiti switches, and these are connected to the internet.
Right. Right. Right.
Okay, so
Hmm.
we
I
have a
will.
yeah.
Yes, let me draw some lines. So these were the green ones, right? So we have explained all of the stuff, but I am, maybe it's good to do some drawing stuff to show a little bit the complexity or how
Yes.
complex it can get. So let me, try to do some lines here. So you would, on node number one, I would take the storage and set it to this one, right?
Right.
And for the redundancy reasons, or let's maybe draw first the nodes on one side. So I do the same for the other node, right?
Yeah.
Then on the other side, I use that switch here, right? Let's do it. And then what about the additional adapters you have here, the second port for the storage? Would you do it
Yeah.
on the left-hand side switch or on the other one?
So if we put it in the left switch, that is in the side, if we have only two switches,
Mm,
and you have to update the switch, or the
mm.
switch
Ah,
nowadays is like a computer, right? It has a
single point
lot
of
of
failure.
software on it, and
Okay.
maybe there is something like a blue screen. Yeah, I call it
Okay.
black screen because it doesn't have a monitor attached to it, or you
Mm,
have to update the switch. All the communication in that side, at least what's connected to that switch, wouldn't be possible. So we need some redundancy.
okay.
And in this scenario, you would connect this adapter to the other side, right?
Okay. Yeah, I got it. And I agree on this one. So let's do it the same way for the other one as well, right? So
Yeah.
let's draw it there. And let's do the stuff for the other nodes as well, which is going that direction here. And
Yes.
one more time.
Yeah.
Okay, got it. Okay.
Yeah. These
But
are the
now,
blue ones. Yeah. The blue ones are
yeah.
connected from one side to another. You can do that if you
Hmm.
buy fiber
Hmm.
GBICs, yeah,
Hmm.
and use a long fiber cable between the sides. So on a campus cluster where we maybe have 50 meters, 100
Mm,
meters, 200 meters between the sides, you can do that. But this
mm,
is not the whole truth here. We
mm.
also have to do it for the green ones. So for the
Yeah.
VM adapters, there's another
Okay.
VM adapter, and the VM should also be redundantly connected. So we would get another 4 cables that are
Hmm.
interconnected between the sides. Don't get
Well,
me wrong. I've seen these scenarios at customers.
yeah.
They work,
Hmm.
but it's not my preferred way. I understand if a customer gets a 4 node cluster, he maybe wants not to buy 4 high performance switches because they're also expensive,
Hmm.
but they have to do a lot of fiber connections between the sides, and it's getting very complex. So if you would
Hmm.
put every line here from the 4 nodes, it's a mess, right?
Yeah, and I'm
You,
not doing it. I mean, I get the point, right?
yeah,
And it's not an ideal setup, right? Because you may earn or get some inconsistencies in the latencies, right? So the reddish
yeah,
lines might be fast, whereas the blue lines are, lagging a little bit behind. Might not be much, but you're adding some asymmetry to
yeah.
that system, right?
And
Okay.
the 100 gigabits GBICs could be getting expensive. So on in the end, you have really to calculate if it's cheaper
Okay.
to do these cables with the expensive GBICs,
Hmm.
or buy another 2 switches and use duck cables that are directly connected to the switches.
Okay.
Um, so
Mm,
why are customers doing that? Let me add
yeah.
one additional word. This is the right design if all the nodes are in the same site. You
Hmm.
need 2 switches for the for the storage here, and 2 switches for management. That's okay. But
Hmm.
if we stretch it over sites, yeah, and
Hmm.
if we go to a metro cluster that is tens, 20s, hundreds kilometer apart, we should not do that because we don't have the many cables or many
Get it.
connections between the sites. Then we should have multiple switches, and I prefer that on the campus also. So we have another picture. Yeah,
Hmm.
maybe
Okay.
Bernhard, to show it how you should do it, but unfortunately we don't have the budget here, and we don't want to lie to you that we have that. We don't have that, but this is the design we would like to have. And if you could add the SMB adapters, maybe draw them. Yeah.
Hmm.
First, let's do all the. There is more. We have more connections here, so do more. Yeah. And there are 2 more I get. I think. Yeah. We have to connect also our switches. Go back to our 1 gigabit infrastructure because the VMs are still on the switches down there, right? So now,
Hmm.
Bernhard, if you now connect only the high performance storage NICs, the 2 on each side,
Hmm.
yeah,
So I would do it that way, right? So let me
yeah,
also take now the blue maybe for the second port, and I would go, this one should go here, and that
yes,
one is going there, or
yes,
sort of this one goes there, and that one goes here,
yes,
right? Sort of, right? I mean, you may have chosen different colors for the different paths, but and so
yeah.
that would be the
So
redundancy, I
this is
think.
this is a way we could do it, and
Mhm.
now the connections are only in the side, and the
Mhm.
long cables are only the 4 red ones between the switches. And this is only
Yeah.
one way how you can do it. You can also use only one cable between the two
Mhm.
switches because we have redundancy over the other 2 switches. So in this scenario, we would have 400 gigabit between the sides. Maybe 200 are enough. Yeah?
Mhm. Okay.
And here, of course, if you build something like that, it's a bit complex. You need someone who is really knowledgeable on the switches because we have
Mhm.
to configure. This is like we have circles here. So,
Mhm.
and in Ethernet, you can't have loops, say loops, not
Yeah.
circles, loops. So you have also to configure something that you don't have loops like a spanning tree or fast spanning tree and so
Yep.
on.
Yeah. Yeah.
Yeah. Okay.
So yeah, okay. I think we spent a really a good time, and I think it's good for understanding. But now let's maybe talk a little bit about the reddish lines, right? Because we have traffic passing from left to right. So that means we need to do some routing. We talked in the previous video about the routing on the operating system level, but now maybe let's consider the routing, or let's see how the routing looks like on the switching level, right? On the Mellanox ones. And I think it's your turn to show the menu of the Mellanox switch you're using
Yeah.
for showing a
Okay.
example of the routing.
Yeah. So I switch over to my screen, and we have a red outline over the two cluster networks and the
Mhm.
replica networks, because those are routed over the Mellanox switches. So we will look at a Mellanox switch. The
Mhm.
SMB adapters are also connected to the Mellanox switch, but they are not routed. Yeah.
Right.
And the management, we have here our Ubiquity. The management network is connected to the 1 gigabit switches, the Ubiquity switches. And we will not look at that because there we use a default gateway. So I have prepared a web console of one of my Mellanox. Now it's NVIDIA. It's an NVIDIA switch. Mellanox was bought by NVIDIA. And here
Mhm.
you see the switch with the ports. Here are 100 gigabit ports. They are fully green. And here you see a port that has two green ones. So it's two 50 gigabit ports. So one 100 gigabit port is divided into 50. And here we have 425 ports in one 100 gigabit. Yeah,
Mhm.
we go here to IP routes, and we look at IP route, and we
Mhm.
see here that the switch itself has multiple routes. It has a default route, that is when we want to connect to the switch. The switch is also in a kind of management network where I work over this IP address with the console. Yeah, that's not
Mhm.
important. Um, but here we see additional networks. And if you look here, I still have part of the slide here. So if we look at the cluster 1 network, the 192, 168, 111, we find it here. Here's a 111. And if I move it a little bit to the side, we see here 111 is in VLAN 821, and that's the same here.
Mhm.
So, and all the um, other networks are also here. 113 is here, 107 is here, 109 is here. And if we would move over, we have the other networks also presented here. Yeah.
Mhm.
So, how do you do that with the Mellanox switch? And it's the same, for example, Bernhard has Lenovo switches. You do it the same way, right? When you use your switches for routing, you configure in the VLAN. So here I press on the VLAN. In the VLAN, we give the switch an IP address in the IP range that is represented by this VLAN. So in our case, it's the 111. And I gave it, in my scenario, the first address, so the .1. And the switch then can route from 111 um, to other networks that are known on the switch, and we have multiple. We only use on our hosts, we implemented a network route that we say from the host from 192.168.111, we want to route to 110 because that is the other cluster network here.
Mhm.
So, but the switch could also route between now the other networks because it has a routing table. Yeah,
Mhm.
it could also route from 111 to 17, but
So
we
the
don't need
specific,
that. Yeah,
yeah. So the specific VLAN gets an adapter or an IP address, or is made like an interface, and then
yeah.
you tell it which
Yeah,
IP
and then
address
we
it
can
has.
route here, but on the host itself, we set the host. So if you want, if a host is on the odd side, if you
Mhm.
want to reach the 110 net, yeah,
Mhm.
yeah, we said, okay, if you want to reach the 110 net, use the default gateway 111.1, and it knows how it gets to 110. Yeah?
Mhm.
So yeah, this is our hardware part, or Bernhard?
Mhm. Yep. So this is, yeah, this was about the switches, and now I think we in the next videos we'll concentrate on creating the cluster
Yeah, we will do.
after.
See you there.
See you there.